Good morning, everybody. Today, I'm going to talk about the conservation of energy. Before talking about the conservation of energy, let's talk about what is energy. The energy is of an object is the ability to do work. The energy can be in various forms. It can be in the form of kinetic energy, it can be in the form of potential energy, it can be in the form of chemical energy, it can be in the form of nuclear energy. There are numerous forms of energy. Heat energy, light energy, it can be any form. So the conservation of energy tells you that the energy can neither be created nor be destroyed, but it can simply be transformed from one form to another form. You can never destroy energy. What you can do, we can only change from one form of energy to another form of energy. Here I will talk mostly about three kinds of energy: the kinetic energy, the gravitational potential energy, and the elastic potential energy. The kinetic energy is related with the motion of an object. If an object is in motion, that means it does have the kinetic energy. Here you can see a girl is running. She has the mass and she is moving. That means she has some sort of energy. The kinetic energy of an object is given by half mv squared, where m is the mass of the object, the v is the velocity of the object. The other form of energy is the gravitational potential energy. A girl is holding a ball here, and this is the earth's surface. You can choose any reference surface. So with respect to this surface, this ball is at a height h. When she releases the ball, that means it does have the energy stored in it. It can cross any object. So that means this one has the stored energy, and this stored energy is in the form of the gravitational potential energy. The gravitational potential energy can be given by m, g, h. M is the mass, g is the acceleration due to the gravity, the value is 9.8 meter per second square, and is the height from a given the surface. The other form of energy is the elastic potential energy. The elastic potential energy, let's say you have a spring. If you take the spring and stretch it or compress it, it does store energy that is called the elastic potential energy. For example, a gun. The gun does have the elastic potential energy. When you press the trigger, all the potential energy, the elastic potential energy, is now changing into the kinetic energy. It doesn't matter what forms of energy we have, the units of the energy is always the joule, the SI unit. And I will give you one example here. Let's say, for example, here you have a gun here, and then in this case it does not have any kinetic energy. All the energy is stored in the form of the potential energy, and this is the total energy, and this the K is the kinetic energy, U is the potential energy. In this case, this is your initial energy. Initially it doesn't have any kinetic energy. What it has is the only potential energy. So I'm just equating half mv squared, which is the kinetic energy, to the stored potential energy, and you can calculate the velocity of the bullet. So let me give you another interesting example, as this is only a 5 minutes video. This is a wonderful example here. I might have spent a minute or two, and in this case we're assuming there is no friction into the system, and we can choose a line here. So here I'm choosing the reference here, and now this one, and I'm plotting the graph here. What I would like you to pay attention here is if you look at this graph, the green one is the kinetic energy, and the kinetic energy is maximum at this point. At any point, this one has at this point right here, this one has the zero kinetic energy. The velocity at that point is zero at the maximum point. That means it has the only the potential energy stored in it, and at this point it does not have any potential energy. All it have is the kinetic energy. But this boy is swinging back and forth as there is no any damping motion, there is no any friction. What is happening, simply happening, is the potential energy is changing into the kinetic energy, and this kinetic energy is changing into the potential energy. So there is an oscillatory motion. So simply the kinetic energy is changing into the potential energy, and the potential energy is changing into the kinetic energy. The only thing you have to keep in mind, at this point it has only the kinetic energy and the potential energy is zero. At the maximum point it has all the energy is in the form of potential energy, and there is no any kinetic energy. This is the total energy now. The total energy doesn't matter what it is always the constant. And here you can do the various things. I can introduce any damping into the system. So if I introduce a damping, what will happen now? Slowly and slowly you will see, slowly and slowly this one is changing. Now all the energy is now dissipated in the form of the thermal energy or the heat energy, and that's the reason it comes into to a stop. So what you learn here, the total energy of a system is always the constant. You can only change from one form of energy to another form of energy. And in this simulation, what I demonstrated you, the potential energy, the gravitational potential energy is changing into the kinetic energy, and the kinetic energy is changing into the potential energy. And if you have any question, do not hesitate to contact me. All right. Thank you so much.